Hello, Chem 1A. This is Chapter 11, Lecture Video 4, and we're going to be talking about polar and nonpolar covalent bonds in this lecture video. But before we do, we need to talk, or I need to remind you of electronegativity, because this plays a vital role in determining whether a bond is polar or nonpolar. Now, if you don't remember, the trend for electronegativity that we already covered is up and to the right, but right to left across the periodic table is way more important than up and down. So the more right we go on the periodic table, the larger our electronegativity, and the more up we go, technically, the larger your electronegativity is as well. But up down really is only important when we're comparing two things in the same column for the most part. After that, we're going to talk about what the difference between a polar bond and a nonpolar bond is, and we're going to be dealing with covalent bonds, because everything in this chapter is about covalent bonds. So when we learned about covalent bonds in the beginning, we said, hey, electrons are going to be shared in covalent bonds, specifically valence electrons. But there's two different types of covalent bonds. There's the nonpolar covalent and the polar covalent. Just because we're sharing electrons doesn't necessarily mean we're sharing them equally. The analogy I usually use here is that, like, let's say I have some cookies and I'm on the playground and I'm back in like elementary school, and my best friend comes up to me and is like, hey dude, can I have some of your cookies? Because they're my best friend, I'm going to share my cookies evenly. I have 4, he's going to get 2, I'm going to get 2. That's like a nonpolar covalent bond. But maybe it's just like an acquaintance, somebody that I'm like friendly with, but not like super best friends with, comes up to me at the playground and wants some of my cookies. I have 4 cookies. I'm not going to give them an equal number to me, but I might still give them a cookie, right? So maybe I'll share one of my 4 cookies with them and I'll eat the other 3. That's more of like a polar covalent, where we're still sharing electrons, just not equally. One of the elements, the one that's more electronegative, is going to be a little bit more greedy. It's going to take more of the electrons for itself. Really, whether your bond is polar versus nonpolar is all about electronegativity difference between the two elements in the bond. So usually we say if the difference is 0, this is a pure covalent, or in other words, nonpolar. On the opposite side of this coin is when your electronegativity difference is greater than 1.9. This basically means you're not sharing your electrons at all. The electrons are being transferred, and this is an ionic bond. But if we're in between these two, usually I'm putting here as 0, but technically it's really 0.4 to 1.9. If it's in between these two, it's a polar covalent bond. Electrons are being shared still, they're just not equally shared. So if we look at some bond polarities and their electronegativities, right, as the difference in electronegativity increases, so does the ionic character of the bond. In other words, as we go from a big difference to a small difference, we see increasing covalent character. And as we do the opposite, we see increasing ionic character. So in like an HH molecule, H2 molecule, these two atoms have exactly equal electronegativities. So when we subtract them from each other, we get a difference of 0. However, in HF, H here, F here, F is the most electronegative element on the periodic table, so when we subtract these two, we're going to get a sizable difference, as you can see with our 1.8 difference between those two electronegativities. This is going to be a polar covalent bond. So this is nonpolar. This is polar. And if the difference gets big enough, like between fluorine minus and Li plus, our electronegativities give us a 3.0 electronegativity difference. This is an ionic bond. I can spell, I swear. So as we increase the difference, we see the bond becoming more like an ionic bond until it just eventually becomes one. However, As we decrease the difference, we see it becoming more perfectly covalent. And polar covalent bonds are somewhere in between the two types of bonding. So just to kind of give you an idea a little bit more, right, here's a bunch of lecturing activities. I don't necessarily have to give you these because you can use the trend to figure problems out like this. But if we look at HF, we get a difference of 1.8. We look at CF, we get a difference of 1.5. And if we look at OF, we get a difference of 0.5. And these values I'm grabbing just straight from the periodic table on the right here. But you don't actually need the values to tell that the differences are going to get smaller as we go down. And what this means is our polarity of our bond, the most polar of these is going to be the HF bond. After that, it's going to be the CF bond. And after that, it's going to be the OF bond. Okay, so that's the end of this lecture video. If you have any questions, please let me know. And I will talk to you during office hours or via my email. Have a good day.